somewhat tricky. First of all, let's remove the parentheses. So what's the next line going to read?
So 16x minus 10xy.
10xy prime.
Yep. Minus 10y. Plus, yeah, 6y, y prime.
Okay. We're trying to solve for y prime. So we want every term that has y prime on the left side of the equation, anything that doesn't have y prime on the right side of the equation. Okay? So I'm going to pull out these two and leave them here. And I'm going to put everything else minus 16x plus 10y. In other words, the only things I leave over here are anything that has a y prime in it. Now, what do you suppose the next step is?
And then do divide everything on the left side by the right side?
No. First of all, we need to try to isolate y prime. So what can I do here to isolate y prime? Your first word was correct, divide.
Okay.
But it really should have been factor. Okay, because that's what we're doing. But that's what factoring is dividing. In other words, if I want to pull a y prime out, what am I left with after I factor out y prime from these two terms?
Negative 10x plus 6y.
Now we're to a point where we can divide everything by that.
Okay.
So we end up with y prime equals minus 16x plus 10y, all divided by minus 10x plus 6y. And that can be reduced a little bit. I guess I can divide everything by 2. Minus, and let's switch it so it looks a little cleaner. Going to divide top and bottom by 2. So I have 5y minus 8x is the new top. Down here I have 3y minus 5x. And that's as good as I can get. I can't simplify that anymore. So that is dy dx, or y prime. Okay? So these are kind of the hard ones of implicit differentiation because they require this step right here, where you factor out the y prime from all the terms that are on the left side. All right? Let's let you do number 4. You don't need to rearrange anything when you're implicitly differentiating. You just start from whatever it gives you. Okay? In other words, I don't need to do any algebraic manipulation to get going. I just start. What I'm going to do is I'm going to take the derivative of each side relative to x. And it's worth noting that, because you're going to get here soon enough, probably by next week, where you can take the derivative of both sides relative to another variable. If I wanted, I could take the derivative of both sides relative to t. I could do something like that. Well, how do you do that? Well, now, since x is not t, this would become 14x dx dt. So it doesn't matter what variables are. if you run into a variable that is different than the denominator differential variable, then you have to follow it with the chain rule, basically. And that's what this is. Okay? In this section, we're differentiating everything relative to x, but it's a fundamental principle of implicit differentiation. That's all you have to know, is just explicitly differentiate something unless it's a variable different than the denominator, and if it is, follow it with the chain rule dx, whatever that denominator is. So it's really, in a way, almost simpler than explicit differentiation. Okay, so what's the left side?
14x.
And on the right side?
10y. And then, is it y prime?
Huh?
And then 4.
Yeah, now this one I don't really need parentheses, but I'm going to use them for clarification because it's really easy to get lost here.
Okay.
By lost, I mean when you're applying the product rule, or if they combined it with a quotient rule, there's going to be a lot of terms. And when you have that many terms, parentheses sometimes help in clarification. But I'm going to be able to remove these right after I use them. Okay, so what's the first term?
4.
What about the y?
And then plus
Hold on.
y
Hold
prime.
on. Remember, the first term of the product is the first term times the derivative of the next term. So
Okay.
in this spot here, since you've given me 4x, you must be going to take the derivative of y. Well, the derivative of y is 1, but since it's not x, we have to have a y prime in there also. Now the plus part of it.
Okay. And then plus 4y.
Yes. That part you don't need a y prime because you're not taking the derivative of y, you were taking the derivative of 4x. Okay? Now, because there's a plus sign in front of these parentheses, I don't need them. I'll just remove them. Now what?
Now would we factor out the y, or no?
Gather your terms, just like algebra. Gather all like terms.
Okay.
And by that, I mean put everything with y prime on one side, everything else on the other.
So minus 4y from each side?
Yeah. 14x minus 4y. And then what am I going to do to the right side?
Factor out the y prime.
Okay, leaving
10y plus 4x. And then divide both sides by the 10y by plus 4x.
there's your y prime. Well, almost. In other words, I can divide top and bottom by 2. So there's your answer. 7x minus y divided by 5y plus 2x. All right, let's see if we can find any that are more difficult, a little stranger. Yeah, let's do 7. And then we'll jump to these others where they want the equation of the tangent line. We'll want to make sure we do at least a few of those. But 7 looks like it could be a little tough just because there's a quotient. goes on the left?
6x.
And what goes on the right?
Then would you do 2 plus y times, I guess it'd be 1?
Minus 1.
Minus 1, okay.
Minus 1 what? Minus 1 y prime.
Okay.
Because we're taking the derivative of this numerator. Right? Taking the derivative of that numerator means we're taking the derivative of y. So we have to follow it with a y prime. Okay, we can get rid of that 1. It's just minus y prime. And I'm going to use brackets here, also for clarification. Because what's the rest of it?
The rest of it is 2 minus y times plus y prime, or y prime, I guess.
And underneath?
Underneath is 2 plus y squared.
Now, are you doing that from memory, or are you looking at it on paper?
That one I'm doing from memory.
Good, good. This is something you definitely want to memorize. I told you how I memorized the quotient rule, didn't I?
Yep, and I really like
Start
that
at the
way.
bottom, end at the bottom square. You can't mess it up if you do it that way. Okay, what's the next step here?
So it would be to multiply everything out?
No. Notice why we don't want to do that. Because
Okay.
at some point, we're going to we're going to factor out y prime, right?
Right.
So we don't want to multiply it out. We can factor it out without distributing it. But first thing to do is to try to isolate everything with the y prime on one side, everything else on the other. So the first step would be to multiply by this denominator. Okay, so we have 6x times 2 plus y quantity squared. And I don't square that because who knows what nice things might happen. We might end up with a 2 plus y on the other side that we can just divide by. Okay, so my right side, I really don't need these brackets. What can I do with that numerator?
Is this where you'd factor out the y prime?
Yeah. In other words, I don't need to distribute these. I just need to factor out y prime. And what am I left with?
2 plus y.
Positive or negative?
Negative.
So it's negative 2 negative y.
Okay.
Because I've got this negative sign here I have to deal with. So when I factor out the y, that negative is applied to both of those two terms.
Right.
Okay, and then, so let me use brackets here because they might be worthwhile here. Over here is 2 minus y. Right?
Yep.
Now let's simplify this thing. Well, to remove the inside brackets, I got minus 2 minus y minus 2 plus y. Right?
Yep.
Well, that becomes minus 4. So now all I have to do is divide both sides by minus 4. I have my answer. Almost, not simplified. I can turn this into, I can put the negative sign out in front, 3x, 2 plus y squared, I'm still going to leave it like that, all over 2. In other words, I just divided top and bottom by 2 and put the negative sign out front. And that's equal to y prime. Now, sometimes if you want the left side to be a complete function of x, well, if we can go back to the original equation and solve for y, we can do that if you have a need to. But normally there's no need to do that. As you can see in the next section, we're going to find the equation of the tangent line. Well, that's going to mean we're going to need to solve for dy dx, which will give us the slope, and this point. Well, we can use point-slope format to come up with the equation of that line. Let's do 17, and I'll show you what I mean, and then we'll go back and look at some of these others that have natural logs and stuff like that. Okay, I don't want to lose our time before we get a chance to do these down here, because these are a little harder.
Okay.
All right, first of all, let's implicitly differentiate it so we can figure out what y prime is. Go ahead, I won't write it from scratch. This is simple enough.
Okay. So it would be 2x plus 2y, and then y prime, then equals 0.
Okay, solve for y prime.
Let's see, would it be negative 2x divided by 2y?
Which means negative x divided by y.
Okay.
Okay, and here's our point, minus 3 comma 4, because what they want is the equation of the tangent line. Well, what did we just solve for? The slope of the tangent line. What is the slope of the tangent line? Minus x over y, but at this point, what is it?
Is it 3/4?
Huh? So there's our m. That's equal to m, our slope. What's the general format for point slope?
Y minus y1 is equal to m, and then x minus x1.
It's 11 hours.
Feel it? I don't know what happened there, but...
The computer tells you what time it is.
Oh, that's what that was. Okay.
Yeah.
I was going to say, it was like your voice was slowed down by a factor of 3 and got real... Huh. Okay. Boy, you ought to put a prettier voice in there to tell you.
I know. It sounds like an alien. It's kind of weird.
Sounds like a monster.
Yeah.
Okay. So, let's fill out everything we know to come up with this equation.
Okay. So y minus 4, and then 3/4, and then x, and then I guess it would be plus 3.
And there's your equation. And you can leave it like that. It didn't say put it into mx plus b format, so there's nothing wrong with leaving it in point slope format.
Okay.
Okay. And let's do another one. I'll let you do this one, only let's find a little harder one rather than doing one exactly the same. Let's try 21. Nah, let's try 19.
Okay.
Because there's a product rule. Fun. All right, so implicitly differentiate it, first of all.
Okay, so 2x, and then would it be plus?
Hold on. You want to skip that step every time.
Okay.
If my function is the product of two things, like this, u times v, then y prime is u times v prime plus u prime times v. Okay? You want to do that step without doing this part here. I mean, you don't want to do that, but that's what I see you doing.
Yeah.
Okay, so let's try it again. So,
okay, so 2x. And then would it be 2y?
no, we're not going to take the derivative. Remember, the first term is u times, well, you've already done the derivative of the x squared. So the next term has to be v, just y squared.
Okay.
Okay? Now plus.
Plus. And then 2y.
Well, let's start with what we see visually.
Okay, so x squared.
Okay. I mean, you could do it the other way, but I think there's a certain methodology that you want to go from left to right. You don't want to jump around. You want to have that pattern, actually, where you do it the same way every time when you're using the product rule. You don't want to mix it up. It just makes it harder for the memory to work. Once you find a pattern that's an efficient pattern and do it just like that every time.
Okay.
So x squared, and what else goes here?
And then 2y, and then y prime.
Right. Equals
0.
Okay. Solve for y prime.
Let's see.
Move that over, divide by that.
Okay.
Right? That's what we've been doing. Okay.
So negative 2xy squared divided by x squared 2y.
2's I can take out of there.
Okay.
And now give me my slope at this point right there.
Okay. So it'll be negative 1 over 1.
Actually, you know what? We can simplify this.
Okay.
I didn't simplify it yet. Now what's the slope?
Now it's 1 over negative 1, but then it turns into a positive 1, right?
Yes.
Okay.
It's actually negative 1 over negative 1. So that, what's the equation of the tangent line?
It is y minus 1 is equal to 1 x plus 1.
There you go. So I think you can see at this point that none of these are hard. They're all just following the pattern. Okay, so let's see if we can pick out the hardest ones in both of these sections. And let's see if there's any hard ones up here that we haven't done. That's just quotient rule, quotient rule. These radicals do anything to you?
Yeah, you know what? I'd like to go over one of those.
Okay, let's do number 9. The way to handle radicals in calculus is to turn them into exponents. In other words, let's rewrite this. 2x to the 1/2. And the reason you want to turn them into exponents is because all your differentiation is done using the exponent, right?
Right.
All right. What should I write next?
Would it be 1x?
To the what power?
To the negative 1/2.
So x to the negative 1/2, okay.
And then 2y to the negative 1/2, and then y prime. And then 5. And then y prime, yeah.
Okay. Now what?
Now we want to solve for y prime.
Right.
Okay. Let's see. So this one's tricky for me since it's on both sides.
You know what? Don't let that, it doesn't matter which side y prime ends up on.
Okay.
Left or right. If I want the y prime to end up on the left, I got to do two things. I got to bring this 5y prime to the left, and I got to take this to the right. Well, how can I do it where I only have to do one thing?
Bring it to the right side?
Yeah, bring this term to the right side.
Okay.
So, I'll subtract it. 2y to the negative 1/2 y prime, and erase it from there. So now, with one step, I've got it to where it would have taken me 2 steps had I wanted to have the y prime on the left. Okay? Now what?
Now would we factor out the y prime?
Yep, that's always the toughest step to see. In other words, if you're going to stumble at any point in these processes, it's going to be that one. So remember it. That's really the only tough part, is making sure you factor out that y prime. What's left?
5 minus 2y to the negative 1/2.
And the last step?
Last step would be divide on both sides by the 5 minus 2y to the negative 1/2.
There you go. Now, might be tempting to switch numerators and denominators here, just to get rid of the negative exponent. How's your teacher feel about negative exponents?
That I would have to double check, because I actually take this class online.
Okay.
So
There's nothing really wrong. I mean, in a lot of precalculus classes, they'll say, make sure you don't have any negative exponents. But it's not that easy to get rid of the negative exponents here. If I didn't have this 5, it'd be relatively easy. And I can certainly move the x to the bottom and put a plus 1/2 on it. In other words, I could do this if I were so inclined. But moving the y to the numerator, not so easy, because the 5 doesn't go in the numerator. So I would just leave it with negative exponents. In fact, I'd have left it like this, I think.
okay.
Not sure how to get that y into the, you'd almost have to do a rational, a multiply by a conjugate, not conjugate, yeah. And what's the word? I keep wanting to say conjugate when I mean something else. In other words, 5 plus 2y to the negative 1/2. And that probably gets the y out of the denominator. But it's such work that there's nothing wrong with this answer.
Okay.
Notice if they gave us a point for x and y, it'd be relatively easy to plug it in and solve for it, right?
Yeah.
All right. But this was not a problem where we have to do that. So, all right. So, as all that was using fractional exponents, and that's all these are here also.
Okay.
So,
can we go over 13?
Yeah.
That's one I have problems
Right,
with.
right. Okay. And I'm just looking at 12 also. The way to do 12 is to apply this to each of these variables. So make that x to the 4/3 times y to the 4/3 and then begin. Still using the product rule, but distribute that exponent first to both variables. All right, 13. It looks scary, but it isn't.
Okay.
It's just the chain rule. So, I want to do the derivative of both sides with respect to x. What's the derivative of the left side?
Is it 2x?
It's the derivative of the outside times the derivative of the inside. Okay? If it's ever confusing, then make up a variable and let it equal this funny part here. Okay? Now we would be differentiating e to the u. Well, the derivative of e to anything is e to the u times the derivative of u. Okay, that's the thing about the chain rule, is you need to figure out what's the inside and what's the outside. So the outside, when you take the derivative of e to an exponent, the outside derivative is e to that exponent. Now you have to take the derivative of the inside. The inside is this exponent. So implicitly differentiate that exponent.
Okay. So 2x. And then...
Notice where my pencil is.
Is it...
Product rule. The derivative of this term times this term.
Okay, so y.
Plus the reverse.
Okay.
Okay? Don't need a y prime because I'm not differentiating y. I'm just differentiating x at this step.
Plus x squared. And then y prime.
There you go. So there's the derivative of the outside, and there's the derivative of the inside. And then differentiate the right side.
5. And then it would be 4 y prime.
Next step.
Would it be get y prime by itself?
Yeah. That's not as easy. In order to get y prime by itself, we need to distribute this over here.
Okay.
I think. Let's see, if I just move this 4, yeah, I've got to distribute this because after I distribute it, I'm going to have a term that does not have y prime in it and needs to go on the other side. Okay? So let's distribute it. Here, I'll just do it real quick. Now I'm going to bring this 4y prime to this side. Now I'm going to take that term to the other side, factor out the y prime. Whoops, hold on. Let me take this term to the other side first of all. Now factor out the y prime from those two. With me?
Yep.
Divide everything by that. Hi, hi, hi. Sorry about that. That's the only thing about doing these online that is a little problematic.
I understand. We have dogs too,
Yeah,
so.
it wouldn't be, I mean, yeah, well, I don't know what to do about it. I wish I could make her shut up when I tell her to. She doesn't follow. She actually follows directions pretty easy. She's a very smart dog, but
What kind of dog is it?
she's easily distracted. It's a mix between a Chihuahua and a Terrier.
Oh.
A little black and white dog.
Yeah, cute.
Yeah, she's cute. Okay, I don't think I can simplify that any.
Okay.
I don't see any way I can divide top and bottom by anything to reduce that. So we've got our y prime. Certainly if we had a point that we were trying to evaluate the slope at, we'd be able to plug it in over here real easy. That's why you don't care if you have x and y over there. Now, let's say that they said evaluate this point at x equal 2. How would I proceed?
Would you plug the 2 in?
Well, I'd plug the 2 in for x, but what do I do about y? Go back to your original function. We're doing 13.
Yeah.
Plug x in for 2 and solve for y.
Okay.
In other words, if they give you just one point and not a coordinate, you can always go to the original function and figure out, well, what is y when x is 2? And that's not the easiest thing to solve either. You got to use logarithms to do that, but you can do it. So it doesn't really matter whether they give you both coordinates or not. If they just give you one, you can go to the original function and solve for the other one. But usually on these problems they give you both, as these problems illustrate. All right, let's see. We got about 10 minutes. Should we do a log one?
Yeah. That sounds good.
Let's do 15. Implicitly differentiate that.
So be 1. And then this one I always have troubles with.
Just you got to memorize what the derivative of natural log is.
Is it 1?
It's the reciprocal of 1. It's 1 over y.
Okay.
Okay. Since we're differentiating y, what else do we need here?
Y prime.
It's the right side.
It is 2x times y to the third.
Good.
Then plus x squared 3y to the second, then y prime.
Good. And that's the way I would always do it. I would never try to put that 3 in front until afterwards, just because it messes up your method. In other words, you want to do it step by step, left to right. I can always put that 3, switch it once I'm simplifying. And what now?
Now we want to get y prime by itself.
Okay. So what's the next step? In other words, a lot of the times these become hard algebra problems. The calculus becomes easy, but the algebra becomes a little tricky. Let's start with moving stuff. In other words, gathering like terms, and that kind of thing.
Okay.
Which terms are going to be on my left? The y prime terms. Okay, so how do I get all the y prime terms on the left, everything else on the right?
Okay, so would you move the y prime from the right side first?
Yeah, okay, and then I'm going to move this 1 over to the right. But there's a term that's got y prime in it, so I got to leave it on the left. Minus, now I'll put the 3 in front. Right?
Yep.
Now factor everything.
Okay. So it'd be, would that be 1 over y? Let's see, minus 3x squared, y squared.
Okay. Now I'm going to divide everything by that. Now, is there anything wrong with this answer?
Is it the y over 1 in the denominator?
I don't know that that's a problem. I can just make that y to the minus 1. Boom. Now, I could factor out a y to the minus 1, but you don't really need to. In other words, I've got an answer now that's equal to y prime, and that's what I'm trying to solve for. Y prime as a function of x and y. I don't care about negative exponents. If you give me an xy coordinate, I can easily plug it in to everywhere I see over here and go from there.
Okay.
Okay. There are some stuff you can do on the right side here that maybe you're not used to doing. I can't do anything to the numerator, but the denominator, I could factor out a y to the minus 1, leaving behind a 1 minus, well, when I divide this whole term by y to the minus 1, I get y to the third there. Notice that if I redistribute it, I get what I started with.
Mm-hmm.
Is this any better than this? I don't know. Probably not. Not worth the factoring. It's only worth factoring if there were something in the numerator. In other words, if I ended up with a y multiplying a bunch of stuff in the numerator, well, now I can cancel it with that. In other words, let's pretend our numerator was y squared minus 2, or minus, no, let's just pretend it's y squared. Okay, well now, by the fact that I factored out this y to the minus 1, I can get rid of it, make that read y to the third. So if it's a situation like that, then it makes sense to factor that out. But in our problem, there's nothing in the numerator that's going to allow me to do anything with that y to the minus 1 once I factor it out of both terms. Because I don't have a y in both terms up here. Let's make this y like that. Now, definitely you want to factor out that y in the bottom, because I can factor out a y in the top, I can factor out a y in the bottom, I can simplify. If there's no way to simplify, don't worry about factoring it. But a lot of times you don't see it until you factor it. So it can be a little tricky. It's especially when you start getting into second derivatives. It's when you start doing second derivatives, especially with a lot of quotients, there's tons of algebraic factoring that needs to be done. And you need to see it because it will cancel out. So just realize that you don't always factor out solid integer exponents. Okay? Sometimes you can factor out, if I've got a y to the minus 1 plus 2x y to the fourth, I can factor out a y to the minus 1 there. Turning this into y to the fifth, I'll have my y to the minus 1 out here, I'll have a 1 here. And that would be useful if, you know, anything simplified with a numerator, but perhaps we better wait until we get those kind of problems before I really confuse you with it. Almost time. Let's do one more that I see here that looks like it could be a little tricky, and that is this one, 25.
Okay.
At least get started on 25 so we can figure out how to handle what's inside here. So, what is the derivative, starting from the left, what's the derivative of the outside?
1, let's see. There's 1 over what?
It's always 1 over whatever the argument is.
Okay.
Okay? No matter how complicated that argument is, it's 1 over that. But, now there's an inside. So I got to multiply it by the derivative of the inside. What's the derivative of the inside?
1. And then
It's not a product rule, just the sum of two things. Differentiate each one.
And then 1 y prime?
Yes.
Okay, or just y prime.
That's how you handle that.
Okay.
Differentiate that. Just that part of it.
So it would be 1 over x squared plus 2?
It's the derivative of the inside.
2x, and that's it.
No y prime, no nothing else.
Okay.
All right. I will let you go.
Okay, perfect.
All right, Molly.
Thank you so much. I will talk to you next time.
Okay, bye-bye. Have a good one.